A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
There is a specific kind of silence that follows the wail of a siren. It is not a peaceful silence. It is heavy, expectant, and vibrates with the leftover energy of an explosion. Yesterday, March 21st, 2026, after the ballistic missiles hit near Dimona and Arad, that silence lasted maybe 3 seconds before the machines took over. But I am not talking about the missile batteries or the radar systems. I am talking about the heavy lifting that happens when the dust is still hanging in the air. It is a moment where the entire world seems to hold its breath, caught between the destruction that just happened and the desperate effort to undo it.
Herman Poppleberry here, and Corn, you are touching on the most critical pivot in any conflict or disaster. It is that transition from an active threat environment to an active rescue environment. Most people focus on the hardware of the defense, the Arrow interceptors or the Iron Dome, but the real engineering marvel is what happens on the ground when the physics of a building or a mountainside changes in an instant. Today's prompt from Daniel is about search and rescue, or SAR, specifically looking at how the mechanics of saving lives translate across different domains like mountaineering, maritime, and urban combat zones. We are looking at this through the lens of yesterday's strikes, which were a massive test of these systems.
It is a massive topic, but Daniel is right to point toward the cross-domain nature of it. We often think of a guy dangling from a helicopter over the North Atlantic as being in a different universe than a home front command soldier digging through concrete in the Negev, but the underlying logic is surprisingly consistent. It is all about managing entropy under a ticking clock. Whether you are fighting gravity on a cliff or fighting a collapsing floor slab, the enemy is the same: time and the laws of physics.
The search and rescue triad is usually defined by mountaineering, maritime, and urban or combat rescue. While the environments are vastly different, they all share what I call the rescue DNA. This is a combination of high-stakes logistics, mechanical advantage, and physiological management. Israel is essentially a global laboratory for this because of the sheer density of its experience. You have the alpine units on Mount Hermon dealing with snow and vertical rock, the naval commandos and Coast Guard in the Mediterranean, and of course, the Home Front Command which deals with the urban rubble scenarios like we saw yesterday in Arad and Dimona.
Is there really a universal DNA there? Because it feels like the skill set for pulling someone off a frozen ledge at 10,000 feet would be fundamentally incompatible with navigating a half-collapsed apartment building. One is about ropes and ice. The other is about jackhammers and structural shoring. How does a technician from one world even speak the language of the other?
The tools change, but the physics of the rescue do not. Think about the concept of the golden hour. In a maritime environment, the golden hour is dictated by hypothermia and the physiological decay of a human body in water. There is a rule of thumb called the 1-10-1 rule: 1 minute to control your breathing after cold water shock, 10 minutes of meaningful movement before your muscles fail, and 1 hour before you lose consciousness from hypothermia. In a collapsed building, that hour is dictated by crush syndrome and the progressive instability of the rubble pile. The professional rescuer in both domains is looking for the same thing: the point of maximum stability to perform an extraction before the environment kills the patient.
Let us talk about that stability for a second. When you are looking at the strikes in Dimona and Arad from yesterday, you are dealing with ballistic missile impacts. That is a different kind of rubble than an earthquake. An earthquake shakes the foundation. A missile creates a localized high-velocity displacement. It is almost like the building has been liquefied and then frozen in a state of chaos. How does a rescue team even begin to assess that kind of mess?
It starts with structural shoring, which is where the engineering really shines. You cannot just start pulling bricks out of a pile. If you move the wrong piece of rebar, the whole thing pancakes. Rescue teams use what they call technical search. They insert fiber optic cameras, or search cams, into tiny gaps in the concrete. They are looking for voids. People survive in voids. But while they are doing that, they are also using geophones. These are seismic sensors that can pick up a heartbeat or a faint scratch against a pipe from 30 feet away. They use piezoelectric crystals that convert the mechanical energy of a vibration into an electrical signal.
I have seen those geophones in action. It is wild because the entire site has to go dead silent. The heavy machinery stops, the shouting stops, and everyone just holds their breath while the technician listens for a sign of life through the earth. It is the most high-tech version of "Is anyone there?" imaginable. It is a haunting moment, seeing 100 soldiers standing perfectly still in the middle of a war zone.
And that is a direct crossover from maritime rescue. If you have a capsized vessel, rescuers will use sonar or acoustic hammers to listen for tapping on the hull. The medium changes from concrete to steel and water, but the methodology of acoustic search is identical. The home front command units actually train with maritime rescuers specifically to understand how sound travels through different densities. A heartbeat sounds different through a wet basement wall than it does through a dry limestone slab. They have to learn to filter out the noise of the environment, the sound of settling debris or running water to find the signal of human life.
That brings up the mountaineering side too. Vertical extraction is vertical extraction, whether it is a cliff face or a 10-story building with the stairs blown out. I know the Homefront Command uses a lot of rope rescue techniques that were originally developed for alpine environments. I remember seeing a drill where they were rappelling down the side of a hospital. It looked exactly like something you would see in the Swiss Alps.
They have to. In an urban collapse, you often cannot use a ladder or a crane. You have to rappel down into a void or haul a litter up through an elevator shaft that is twisted into a corkscrew. The knots, the pulley systems for mechanical advantage, like the Z-drag or the 3-to-1 haul, the rappelling gear, it is all mountaineering tech. One of the most impressive things about the Israeli rescue model is how they have institutionalized this cross-training. You will have a reservist who spends his weekends rock climbing in the Galilee, and on Monday he is using those same Prusik loops and carabiners to lift a 1,000-pound slab of roof off a survivor in a rod.
It is the mechanical advantage that fascinates me. We are talking about human beings moving mountains. But you mentioned something earlier that I want to poke at, the trade-off between speed and stability. In a combat zone, or after a missile strike like yesterday, you do not have the luxury of a slow, methodical engineering survey. There is still a threat. There might be a second volley. How do they balance the get them out now instinct with the don't let the building fall on the rescuer's reality?
That is the rescuer's paradox. If you go too fast, you kill the survivor and yourself. If you go too slow, the survivor dies of their injuries. The way they manage this is through something called marking systems. If you ever see a building after a disaster, you will see these big orange X marks sprayed on the walls. Those are not just graffiti. They are a data-rich language based on the INSARAG standards. One quadrant of the X tells you which unit searched it, another tells you the hazards found, like gas leaks or unstable floors, another tells you the number of victims, both living and deceased, and the last one tells you the time of completion. It allows for a decentralized command structure where a new team can arrive on site, look at a wall, and know exactly what the situation is without talking to anyone.
It is a massive information management problem. And speaking of decentralized systems, we have to talk about the patchwork nature of how this actually works in Israel. You have the military, the Home Front Command, but then you have these volunteer organizations like ZAKA or United Hatzalah. They are often the first ones there because they live in the neighborhood. How does a professional military unit integrate a guy who just ran out of his house with a medical kit?
It is a friction point, but it is also Israel's greatest strength. In a top-down system like FEMA in the United States, everything is very rigid. You have a command bus, a perimeter, and a strict hierarchy. In Israel, it is a hybrid. The Homefront Command provides the heavy gear and the engineering expertise, but they rely on the volunteers for the edge case autonomy. If a volunteer from ZAKA knows the layout of a specific synagogue because he prays there every day, the military commander is smart enough to let that guy lead the way through the basement. This patchwork is actually a highly efficient network where local knowledge is prioritized over rank.
ZAKA is an interesting case because their mission is technically different. They are the identification of disaster victims. Their job is often the most grim, ensuring that every part of a human being is recovered for a proper burial according to religious law. But in the chaos of a strike like the ones in Arad, they are effectively search and rescue. They are the ones crawling into the tightest spots because they are driven by a religious imperative that matches the military's operational imperative.
Their psychological resilience is off the charts. Think about the cognitive load of that work. You are operating in a space that is physically dangerous, emotionally devastating, and technically demanding. To maintain the precision needed to identify a victim while the building is still groaning around you requires a specific kind of mental compartmentalization. SAR professionals across all domains share this. Whether you are a Coast Guard swimmer jumping into 40-foot swells or a mountaineer trying to secure a litter on a crumbling ledge, you have to be able to shut down the fear response and focus entirely on the sequence of operations. It is about moving from "what if I die" to "what is the next step in the knot."
You have been reading a lot about the training pipelines for these guys lately. What does that actually look like? How do you train someone to ignore the fact that a 5-ton slab of concrete is hanging by a thread over their head? It seems like something you either have or you don't.
It is all about stress inoculation. The Homefront Command has these massive training sites that are essentially simulated ruins. They build a structure and then literally blow it up or knock it over with heavy machinery to create realistic voids. Then they bury sensors and mannequins and sometimes live victims and make the trainees find them while smoke machines are going, sirens are blaring, and instructors are screaming. You do it until the technical movements become autonomic. You want the knot tying and the sensor placement to be as natural as breathing, so when the real adrenaline hits, your hands just do the work. They even use biometric feedback during training to show the recruits when their heart rate is spiking and how to use box breathing to bring it back down.
I wonder about the tech shift too. We talked about geophones and fiber optics, but I am seeing more about AI-assisted drone mapping, especially after the strikes yesterday. I imagine they were flying drones into the impact sites before the dust even settled.
That is the new frontier. We are moving from manual search to swarm mapping. You can fly a drone equipped with LiDAR, that is light detection and ranging, into a collapsed structure. In minutes, it creates a three-dimensional map of the internal voids that is accurate to the centimeter. It uses SLAM algorithms, simultaneous localization and mapping, to navigate without GPS, which obviously doesn't work inside a pile of rebar. This takes the guesswork out of the engineering. Instead of a commander saying, "I think the basement is over there," he has a three-dimensional model on his tablet showing him the exact path to the void.
It feels like that would be incredibly useful for maritime rescue too. If you have a sinking ship, knowing the internal layout and which compartments are flooded in real time would change everything for the divers.
It already is. They use autonomous underwater vehicles, or AUVs, to map hulls, but the big challenge in maritime is the transition. Getting from the air into the water is the most dangerous part of the rescue. That is why the cross-training with mountaineering is so key. The winch operators on rescue helicopters are essentially high-speed alpine guides. They have to manage cable tension, wind shear, and the movement of the vessel all at once. If the cable snags on a mast, the helicopter can be pulled right out of the sky. It is a high-stakes dance of physics.
Let us go back to the human element for a second. You mentioned the rescuer's paradox and the psychological load. I am curious about the long-term effects. These guys see things that most people cannot even imagine. After an event like the March 21st strikes, the news moves on, but these teams are still processing what they found in those ruins.
There is a high rate of burnout, but there is also a profound sense of purpose that acts as a buffer. In the rescue world, there is a concept called the Brotherhood of the Rope. It started in mountaineering, but it has spread. It is the idea that your life is literally in the hands of your teammate, and theirs is in yours. That bond creates a level of resilience that is hard to find in other professions. In Israel, because so many people serve in the reserves, this bond extends into the civilian world. The guy who was digging you out of the rubble yesterday might be your accountant next week. This lack of social distance creates a unique support network.
That is a very Israeli dynamic. The lack of distance between the hero and the civilian. It makes the whole society feel like a giant SAR team sometimes. But what about the mistakes? We do not often hear about the failed rescues. What happens when the physics wins?
It happens more than people like to admit. Sometimes the environment is just too unstable. There was a case in a mountain rescue context where a team had to make the call to leave a victim behind because the avalanche risk was at 100%. It is the hardest decision a commander can make. In urban SAR, it is the same. If a building is creeping, that is the technical term for when it is slowly shifting, you have to pull your teams out. You cannot trade 4 lives for 1. It is a cold mathematical calculation that goes against every instinct a rescuer has. They use laser interferometry now to monitor that creep. If a wall moves even a fraction of a millimeter, an alarm goes off on every rescuer's vest.
That is where the engineering comes back in. If you have better sensors that can detect creep at the millimeter level, you can stay in longer. You can push the boundary of what is possible. It is about using data to buy more time.
And that data is being collected long before the incident. One of the takeaways from the Arad strikes is the importance of pre-incident mapping. Israel has been digitizing the blueprints of almost every major structure. When a building is hit, the SAR team doesn't just show up blind. They download the digital twin of that building. They know where the load-bearing columns are, where the gas lines run, and where the safe rooms or MAMADs are located. This pre-incident data is the difference between searching for hours and searching for minutes.
It is amazing how much of this comes down to trust. Trust in the tech, trust in the teammate, and trust in the training. Looking at the broader picture, how do you see SAR evolving? We have talked about drones and AI, but is there a limit to how much we can automate the actual saving part?
You can automate the search, but the rescue is still a very human, very manual, labor-intensive process. You still need a human being to crawl into a hole, look a survivor in the eye, and provide the psychological anchor they need to stay alive during a 4-hour extraction. You can send a robot to find them, but a robot cannot provide the comfort or the nuanced medical care required when a limb is pinned under a girder. There is a physiological phenomenon where a patient's condition can stabilize just by the presence of a rescuer.
The human touch. It sounds cliché, but when you are trapped in the dark under 6 feet of concrete, hearing a human voice is probably the only thing that keeps your heart beating.
There is actually medical evidence for that. The will to live has a measurable impact on survival rates in trauma cases. Rescuers are trained in crisis communication. They do not just shout, "We are coming for you." They give specific instructions. Tell me your name. Tell me what you can see. Wiggle your toes. It keeps the victim's brain engaged and prevents them from slipping into a shock-induced coma. It is about maintaining a cognitive link between the survivor and the outside world.
It is a fascinating intersection of high-end engineering and basic human empathy. I want to shift gears a little bit to the practical takeaways. Most of our listeners are not going to be home front command officers, but after seeing what happened in Dimona and Arad, people are feeling the weight of their own lack of preparation. What can a regular person actually do to bridge the gap before the professionals arrive?
The biggest thing is stop the bleed training. In a mass casualty event, the leading cause of preventable death is hemorrhage. You can buy a high-quality tourniquet for $30 and take a 2-hour class. That single skill is more likely to save a life than any other piece of gear. Beyond that, it is about situational awareness, knowing where the load-bearing walls are in your own home or office. If the sirens go off, you want to be near the structure that is least likely to pancake. Usually that is near the elevator core or the reinforced safe room.
And what about the patchwork system? Should people be looking to join these volunteer organizations?
Organizations like ZAKA or local search teams are always looking for people and not just for the frontline work. They need logisticians, radio operators, and people who can manage data. The more civilians who have even a basic understanding of how the SAR system works, the more efficient the system becomes when a crisis hits. It reduces the chaos. If you know how to mark a building or how to report a hazard using the standard language, you are helping the professionals move faster.
It is about becoming a useful node in the network rather than just a casualty. That feels like a very proactive way to deal with the anxiety of living in a world where ballistic missiles are a reality. It turns fear into a checklist.
It is the only way. Resilience is not something you have, it is something you build through preparation. The SAR professionals we are talking about today are the elite, but they rely on a foundation of a resilient public. If the public knows how to evacuate, how to perform basic first aid, and how to stay calm, it frees up the specialists to do the impossible jobs. The goal is to create a seamless interface between the civilian who is first on the scene and the specialist who arrives with the heavy lifting gear.
We have covered a lot of ground, from the physics of concrete to the psychology of a Coast Guard swimmer. It is clear that while the domains are different, the mission is singular. It is the ultimate test of human systems integration. You are taking the best tech we have and putting it in the hands of people who are willing to walk into a collapsing building.
It is the highest calling of engineering, in my opinion. We spend so much time building things, but the science of unbuilding them safely to save a life is where the real genius lies. Whether it is a mountain, a ship, or a missile strike, the goal is always the same, bringing someone home. And as we move into an era of autonomous swarm robotics and AI mapping, that mission will only become more precise. We are getting better at finding the voids, and we are getting better at reaching the people inside them.
It is a good place to start wrapping up. We started with the silence after the sirens in Demona, and we've ended with the future of human-robot collaboration in the ruins. It is a heavy topic, especially given the events of the last 24 hours, but there is something deeply hopeful about the fact that this level of expertise and dedication exists. It reminds us that even in the face of high-tech destruction, the human drive to rescue is even more sophisticated.
It is the insurance policy of civilization. We hope we never need it, but we are incredibly lucky that people like the Homefront Command and ZAKA spend every waking hour getting ready for it. Their training is the reason that 3 seconds of silence doesn't turn into a lifetime of it.
Well said. I think we have given people a lot to chew on. Before we go, we should mention that if you want to dive deeper into the military side of this, check out episode 927, That Others May Live, where we looked at the mechanics of combat rescue. And for more on the Israeli emergency response specifically, episode 1244, Racing Against Time, covers that decentralized lifeline in detail.
Great recommendations. And of course, a big thanks to our producer Hilbert Flumingtop for pulling all the research together for this one. It was a heavy lift, no pun intended.
And thank you to Modal for providing the GPU credits that make this whole operation possible. This has been My Weird Prompts. You can find us at myweirdprompts.com for all our episodes and the RSS feed.
If you found this episode helpful or interesting, please leave us a review on your favorite podcast app. It really does help other people find the show and understand these complex systems.
We will be back soon with another prompt from Daniel. Until then, stay safe. Check your emergency kits, and keep looking for those voids.
Goodbye, everyone. Stay resilient.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts, that's the flows from slow